Um, okay, cool. So, welcome back. Hope your break was good. Hope you did as little schoolwork as possible, if any.
I just meant to press the mic off, not to exit the call. My bad.
These last couple weeks to get you ready for what's coming. So we're going to do a couple things. Number one, today will be the only day where we look at 2.3. Right, we did 2.1, we did 2.2 already. We're going to look at 2.3. But in a pretty kind of superficial way. We're just going to skim the surface. I'm just going to kind of show you the basics, because if I start the whole section, no way we finish it. Mute yourself if you're not muted. If we start 2.3 and I try to do the whole thing, we'd have no time to review for the final, and you wouldn't be as prepared as I'd like you to be for that. I would rather just kind of skim the surface, like I said, of 2.3, start it, show you like just one super simple idea, give you tomorrow to practice it, and then starting Wednesday, when we come back live, because you only have to be live Mondays and Wednesdays, everything else I will either just hold office hours that are optional, or just invite you to come if you feel like it. What I want to do is just kind of start reviewing. So to that end, what I'm going to do real quick, I'm going to share my screen so you can see what I just posted on Canvas. Okay. If you go to our class and you click on assignments, okay, all the way at the bottom, very, very last thing is our final exam, okay? Now, I haven't written it yet, obviously, because I just started talking about it, but I just kind of wanted to break down what you should expect and when, okay? So first things first, obviously you guys are period 7, you're gonna take it at the period 7 time during finals week, okay? So that's Thursday, December 17th from 8 to 9:30. Okay, I don't think it's going to take us an hour and a half, but you'll have the whole hour and a half if you need it. Okay, you might be finished in 45 minutes. But I am going to try to get everything on there. Okay, but how you're going to do it, obviously, is going to be virtual. As we get closer, these 2 spots will end up being links to a Google Meet that you will join with your camera on. And I love that your cameras are on right now. It's so nice to see you guys. Throughout the whole test, okay, your camera will be on. But you're going to take a test that's mostly going to be just kind of like multiple choice questions from the stuff that we've talked about, okay? So how you're going to do it, right? Obviously, you log into Google Meet, but approximately just a minute before 8 o'clock on Thursday the 17th, you check your Canvas inbox and I will send you a link to the multiple choice test itself, okay? It'll be a Google form. Every question will be multiple choice, okay? And questions that have work required, like systems of equations or finding the vertex in standard form with the whole negative b over 2a thing from before break. Those types of questions will need that separate work uploaded. Okay, you won't be able to get 100 just by getting every question right. You're going to need to have the work to back it up for some of the questions. Obviously, not all of them. Like a transformations questions, there's no work there necessarily, right? Talking about the vertex within vertex form, not a whole lot of work to show there. So those I might just say, you know what, you're good. Just pick the right answer and you get all the points. But on the questions that say work required or something like that, what you'll do, because that right there is an assignment in Canvas, after you take the final, once you're done, take a picture of all of the scrap work that you've done, whatever handwritten work you think you need to, and especially the ones that say are mandatory work to be shown. You'll just take a picture and upload it like you do everything else to Canvas, okay? The ones that don't take any separate work, you do not have to actually upload anything to get all that credit, okay? Sorry, let me go back to this. crazy. All right, cool.
Rosie,
Question.
will we be able to use our notes and stuff on the final?
Absolutely. Yeah, everything that we've been doing so far, absolutely. There's going to be a lot of different things, right? Because if you look below the how, right, which talks about checking your inbox and being able to upload any of that separate work there, there's a bunch of stuff that we've done already, right? Solving equations, domain and range, min and max, increasing, decreasing, transformation systems, all this stuff with quadratics, all that stuff is all going to be on there. So yeah, I would really, really like to allow you guys to use notes for stuff like that, so I can make sure that even though it's a final, you've got all this really good work that you've done over the last 4 or 5 months. I want you to reap those benefits, okay?
Are we allowed to use digital notes?
Say that again?
Are we allowed to use digital notes?
Like look up the answers online? No.
That's not.
No. You like.
No,
what do you mean digital notes?
Like I transferred my notebook into like a digital notebook, so I didn't have to. So I could throw away all my paper.
Okay. If it's your work, you can use it.
Okay, cool.
If
Thanks.
it's your work, you can definitely use it. You cannot be looking at other people's work to do this. This is still kind of just an individual kind of thing. And so because I'm making this multiple choice, because I'm doing it online, obviously we have to. I just hope that you guys know that I'm trying to give you the best grade possible. So I will make the test reflect that. As long as you kind of do what you need to do over these next couple of weeks, you'll be fine. And so to get to that point, what I want to do starting Wednesday is I want to start reviewing.
Yeah, are we going to get a study guide?
Wednesday, Monday, Wednesday, over this next week and a half, I'll be doing kind of like mini lessons for each of the things, kind of going over questions that you might be struggling with. And I'm going to send out by Wednesday at some point a study guide. And once I do them, I'll send you the solutions as well for every kind of question that I could ask. So you've got this one space where you can go and look and say, okay, what do I need to do for section 1.1? Well, boom, I go to that section, and there are the kinds of questions he's going to ask. The only thing that's going to be different are the numbers, right? But the exact type of questions will all be there. And so to encourage you to make use of that review, what I will do is make it 1, optional, but 2, extra credit. Okay? If you complete sections of the review, and so I'll kind of break it down by section. A chapter 0 section, a 1.1, a 1.2, a 1.6, a 2.1, a 2.2, and a 2.3 section. For each of those sections, if you do the review and you submit it, I'll kind of create separate assignments for them. They'll be optional, but extra credit. If you do them, I'll give you some extra credit points for them, kind of helping build up your grade going into the final exam so I can grade the final the way the final deserves to be graded, right? Because some of us are at a grade that really we would like to improve over these next couple of weeks, but we're not going to have a test. That would be crazy, a test right before the final. I don't want to do that. I would rather give you a chance to boost your grade with like making up old missing work. So if you are missing something, get it to me and let me know that you've submitted it, right? Anything basically 1.6 and beyond, I'll take. Okay, so systems of equations and any of this quadratic stuff I'll take. And then all of this review stuff that I will send out starting at the latest on Wednesday, I'll send it out. You can kind of work through section by section, upload your work to Canvas, and I will like throw you a point or two or something back on whatever assessment we had for that section, okay? Or I'll make an extra credit spot on Infinite Campus out of 0 points and give you however many points I say you can do. And the more work you do, the more work you get back, the more points you get back. So more to come on that. I just kind of had that thought here in the last, not all that long, last couple minutes, honestly, I thought of that. But just real quick, one more time. I see you, Zach. Yeah, I see you. Everybody sees you.
Dallin, why do you have Trump hat when the election's over?
What?
Why do you have a Trump hat on when the election's over?
It's not over.
All right,
It's over.
there you go. So there you go. That's all right, let's do this. All right, take us something to write on. Chapter 2, Section 3. I want to just take like not even a half hour if I can. I want to see if I can get you guys out of here before 2 o'clock. Just the basics of how to deal with this section in a very easy way. Now, you'll see when we get back to January, we're going to start fresh with this section and really dive a whole lot deeper. And honestly, besides chapter 0 with solving equations, being able to do that, being able to do what we're going to do in January with this section is probably the most important thing that you take away from this whole chapter. So that's why I want to devote basically most of January to just this. But I wanted to give you a good background on it today so I can practice tomorrow and put it on the final so you've got a pretty good idea. Okay, we've looked at vertex form, we've looked at standard form. Now we're going to look at what's called factored form. F-A-C-T-O-R-E-D. Okay, and I know that this is stuff that you've done before. Absolutely, I know you've done this before. It's definitely an Algebra 1 kind of thing. But we're not going to I'm not going to factor with you in December, November 30th, whatever, December, these last couple of weeks. I'm going to give it to you factored. It's already going to be factored. We're going to do the factoring part in January, okay? So I'm kind of like giving you the problem halfway done already. You just need to finish it, okay? And so here's what it looks like in general, okay? Whatever the function is, right? It could be y equals, but most of the time we give it a function name, so call it f of x or whatever. It still starts with a, okay? That is always going to be first. I don't care if it's vertex form, standard form, or factored form. That vertical stretch or compression is still there. You know, to tell if this thing is flipped upside down or not, that number is still there, right? If a is positive, up we go. If a is negative, right, that thing opens down. Nothing about that is any different, which is nice, okay? But what you're going to see is that, like in standard form, there was an x squared, right? And in vertex form, there was an x on the inside of some parentheses, but it was still squared, right? We just had that one x being squared, okay? In factored form, we break that x squared apart into 2 different x's being multiplied together. So you're going to have like a set of parentheses with an x in it, leave some space here, and then right next to it, another set of parentheses with a different x in there. And most of the time, those 2 sets of parentheses will be different, okay? They could be the same. It could be x plus 2 and then x plus 2 right next to it. All right, that's x plus 2 squared. That's kind of what vertex form looks like anyway. But most of the time, they'll be different, okay? So what I wanted to do was kind of take a second, let me reshare my screen for a second, and give you a way to look at some kind of equation. I'll just put y equals right now, it doesn't matter. And see if you can give me an idea. Let's make that smaller so you can see the whole thing. What happens when we write it factored? And right now, a is just 1, right? There's nothing in front of the equal sign, so a is just 1. So that's why it opens up. So it's still a is just 1. But what those numbers in here actually represent in terms of the graph, because we found vertex, we found the y-intercept, we figure out this thing opens up or down. What's left? Like what's the only other set of points that we really haven't talked about? Look at vertex, God, I keep saying that. Look at factored form. And tell me what these numbers on the inside give you just by looking at it. Unmute yourself and tell me what you think you see. X minus 2 and x plus 1 are your factors. Find some spots on this graph that relate to those numbers.
-1, 0.
So there's a point -1, 0, okay? So you had an x plus 1 and -1 was an x-intercept, okay? And?
Point -2.
Right? You've got
Yes,
an nice,
Oh,
right?
thank you.
-2 and +2 is an x-intercept. And so both of those numbers just end up being x-intercepts. We just have to switch the sign, right? But it all comes back to it being just x on the inside. We can switch the sign, which makes sense because if you think about it, like that's like two separate horizontal transformations, and horizontal transformations are always back. So we always just switch the sign of whatever that number is on the inside, which is why in kind of general factored form with no numbers in it yet, I'm gonna put a minus in here, just like I did with x minus h squared in the vertex form to remind you to switch the sign, okay? Now, we could have other things in there besides x. It could be 2x or 5x, and that's gonna mess with things a little bit, but we'll get to that here in a second. But those numbers right there, right, those are your x-intercepts. Those are called the roots of this equation, okay, the x-intercepts. But I'm going to use the word roots. I mean, think of like the x-axis as the ground, right? The roots of the tree, right, that meet the ground. Perfect, okay? And I'm going to use r to talk about them, okay? So you've got like this x minus r over there and an x minus r over there. But those r's could be different, so I'm going to put like a little 1, so it's r sub 1, and a little 2 right there. So you've got like x minus r1 and an x minus r2, because you could have two different roots, right? Just like we do in this picture. Let me stop sharing so you can see that a little bit bigger. Here we go. Pin me so you can see me a little bit. There we go. Okay, so that's what this thing looks like, all right? It's going to be split apart into two separate sets of parentheses, where if it's just x on the inside, if you want to know the x-intercepts, just pick the number that goes with it and flip the sign. Okay? So I don't know if you've got something like, call it number 1, f of x equals x minus 5 and x minus 3. What are those roots?
I'm gonna lie. I don't know.
There's that function, right? Y equals f of x, g of x, whatever you want to call it, right? X minus 5 and x minus 3. What are those two x values? You can call them x, you can call them r1, r2. Let's call them r1. R1, r2. Or you can call them x equals, that's fine. What are those two spots? Visually, just look at it. Where does it run into the x-axis?
3, 0, and 5, 0. Right?
X.
No.
Yeah, absolutely, yeah. Right? This spot right here, 3, 0, and this spot right here, 5, 0. And if you look at the equation, it gives you those numbers. It's just x. It's not 2x or 5x or 9x or whatever. It's just x. X minus 5, okay, take that number, switch the sign. Positive 5. X minus 3, okay, it's just x. Switch the sign of the number, so it's positive 3. And that's it. If it's just x in the equation, you don't have to do anything but switch the sign of the number that goes there. Okay?
Peep Mr. Bricker.
Let's do another.
No.
All right, look at this one. G of x, I call something different, so I call it G of x. X minus 4 and x plus 2. All right, again, that number in front is just 1, so I know this thing opens up. This number in front is just 1, so I know it still opens up. So I still have a minimum at the vertex, but I don't really care too much about the vertex. I just care mostly about where I'm running into the x-axis for now. If this is x minus 4, all you have to do is switch the sign of that number, call it a positive. Okay? This is x plus 2. It's just x, not 2x or 5x or anything like that. All you have to do, switch the sign and call it negative 2, and you're good to go. Are we good? Okay. Now, here's where things take a turn. Okay, and this is the last thing that I want to do, is talk to you about what happens if it's not, I don't know, I'll call it h of x, whatever. What if it wasn't just x on the inside? So you got like x minus, what have we done now? Like 6, but then like 2x minus 1. Right, and all I'm trying to figure out, I'll just draw it whatever like that, right? What that spot is and what that spot is right there. Call it x-intercepts, call it roots, call it whatever you want. They're points, right? If you are on the x-axis somewhere, wherever it happens to be, whether it's here, here, or anywhere on there, right? You're at some point, some x value. What is the y value at that spot? No matter where you are on that x-axis, if you haven't gone up or down, what's the y value at that spot?
It would be 0. Ah, he did it.
And if h of x is really just y, then all I'm really trying to solve at this point is an equation that looks like that. Take the function, set it equal to 0. Why? Because it's just 0, right? But how are we going to separately solve for two different x's if they're written next to each other? Okay, and that's a problem that we run into. Is you find this, right? This quadratic. So it's got x squared, and I can't really solve for that if it's got x squared and it's got x and it's got a number, and that whole thing just really falls apart if you think of it all together. But what I want to try to do with these last few minutes is give you an understanding of how this idea, solving for the root, solving for the x-intercepts, where y is 0, is really just solving this equation, where you take the function. So here's how we're going to do it. Set the function equal to 0. Why 0 and not anything else? Well, because we're on the x-axis and y is equal to 0. Okay? But how are we going to solve that? Right? And so think about it like this. All right, I've got two things. Something times something else. Right? Something, there's one thing, times something else. Okay? And it's equal to 0. All right, there's our setup. Okay? I'm going to get to this in a second, but what if it wasn't equal to 0? What if it was equal to 10? Whatever, I'm making it up. What are the ways you can multiply two numbers together and get 10? Think, just throw out an example of something that works.
Well, if you multiply two numbers, would it be 1 and 0?
Well, what if I was trying to get, so I want the product of two numbers to be 10. I'm not going to do 0 yet. I want to talk about 10 first.
1
If you want to
times
multiply
10.
two things together and get 10, what's one option for both for those numbers?
5 times 2.
5 times 2. What else?
10 times 1.
Awesome. What else?
Shut.
What about -1 times -10? Or -5 times -2, right? As long as they're the same sign, I get positive, right? But what about like 20 times 1/2? Or 50 times 1/5? Or 100 times 1/10? Like there's so many different ways for me to multiply to 10. In fact, there's an infinite number of ways to do that, and that is going to give me a whole lot of trouble in trying to figure out what to do with each of these. Because if this is a 1, then that's got to be a 10. But if this is a 2, then that's a 5. But if this is a 10, then that's a 1. If this is a -1 and that's a -10, and that just is so many choices, right? And so that's the problem with setting this thing equal to 10, which is why we don't do that. I don't care about 10, like finding the spot where y is equal to 10, too many ways to figure that out. But finding the spot where two things, whatever you want to call them like A and B, I'm just making just letters that don't mean anything. Two different things multiplied together to give you 0. If you've got two numbers being multiplied together and the answer's 0, then what do you know about one of those numbers? What does it have to be? Two things multiplied together, two numbers being multiplied together, and you get 0.
0.
Gotta be one or the other, has to be 0, right? And it doesn't matter which one, the answer is going to give me 0. And so I just check both. And I deal with each one separately. Like I take an equation that I really couldn't solve together, right? I can't deal with these both at the same time. I don't really care to deal with them both at the same time. I just want to find the 2x-intercepts, whatever order I want. It doesn't matter. If I look at them separately, literally, I take this one equation and I split it into two. One equation I can't solve, let's split it into two separate simple equations that I can. Because you know what? If I could get x minus 6 to be 0, I don't care what this is, the answer is going to be 0, and I got the right answer. Or if I could make 2x minus 1 equal to 0, I don't care what this is, whatever times 0 is 0, and I found the right answer. So here's my plan, here's my strategy. You've got some set of factors like this, right? Things being multiplied together, that's all factoring means, is just rewrite it as multiplication. You've got two things being multiplied together and it's equal to 0. Look at the first one. If the first one is 0, you're good. And I'll just figure out what's going to make that work. If the second one is 0, I'll just figure out what's going to make that work. Split your work into two. And here's how I do it. Right in between the parentheses, where one set of parentheses ends and the next one begins. Not literally between them, but like the line right below it, I'm going to draw a vertical line to split my work in half. And I'm literally like splitting these factors apart. And if I say, you know what, if I could make the first one, so drop the parentheses, if I could figure out what's going to make x minus 6 equal to 0, then whatever that number is, 0 times whatever is 0, and there's an answer. And I'm just going to solve this one separately. So, all right, there it is. I don't care about the rest of this problem. X minus 6 equals 0 is my equation. What should I do to both sides to get x by itself? It's x minus 6. How do we solve an equation if you've got subtraction and you want to undo that?
Addition.
Yeah, plus 6, plus 6. The 6's are gone, and there's your answer, which we already knew. It was just x. It's a minus 6, so I just change the sign, boom, and I'm done. Right? This one, I do the exact same way. I say, you know what? I don't care about the x minus 6. If I could figure out what's going to make 2x minus 1 equal to 0 on its own, whatever that number is, I could drop in, it's going to make the whole thing 0, because anything times 0 is 0. Okay, now solve this one separately. What should we do first to get ourselves to the point where hopefully we get down to x equals?
Can you turn the computer a little, like to the right, so I can see the board better? Little, the other way, sorry. There you go, that's perfect. Thank you.
Yep. 2x minus 1 equals 0. Start solving that. What should we do first?
Add 1.
Always take care of addition and subtraction first. Okay, 0 plus 1 is 1. Now you've got 2x is equal to 1.
Don't you divide by 2?
Perfect. Right? We want to just do the opposite of whatever's there, right? Now, 1 over 2 is 0.5 or 1/2, call it whatever you want. But once you get to x equals, then you're done. And what we should hopefully see, if I look at the graph of this, is that those are the two spots, right? I've got this x minus 6, and I've got a 2x minus 1.
Poop.
0.5 and 6. Done. So if I just deal with them separately, right, I should be able to get myself to that right answer, right? So set up the function equal to 0 and create two equations, right? Set each factor equal to 0 and solve them separately. And you're good to go. And that's it. Okay, this whole thing over here, if you've got two things that multiply to 0, you can just kind of set them both separately. You've probably heard it in Algebra 1. It's called the zero product property. Zeros, that's what it's set equal to, product, because they're being multiplied together. If you got a couple of things multiplied together and you get 0, just look at them separately. Set them both equal to 0, and you'll be good. Okay? Which means that there's not really a ton of work that you need to do once it's factored, right? The hard part's done once you get to here, okay? If they give it to us factored, man, this is not difficult at all. I mean, I cannot come up with simpler equations than these. It's the factoring part in January. That's the hard part. Trying to get to this is what makes that difficult, right? Okay, let's just do one more just to make sure you got it, and then we'll be done. M of x equals 2x plus 5 and 3x minus 1. Okay, and if all they want to know are what are the roots or what are the x-intercepts, doesn't matter how they say it, the process is still the same. Okay, 2 steps really. Take whatever you've got, exactly as it is, whatever that function is, and set it equal to 0. Okay, that first step is so critical for me knowing what you're looking for. Right? Because we can find the y-intercept, we can find the vertex, I can find some other random points. No, I care about these and these points only. Okay, when I'm talking about the roots. Okay, but because they're next to each other like this is one big equation I can't solve. I got 2 different x's in the problem. I can't solve for them at the same time. So I'm going to solve for them separately. Not actually between the parentheses, but in the line right below it. So just below those parentheses, I put a long vertical line to split my work into 2. Why? Because if 2 things multiply together get 0, if the first one's 0, I'm good, or if the second one's 0, I'm good. So I just check wrong. Okay? And that's what I do. I take the first one, I set it equal to 0, and I see what I get. Take the second one, set it equal to 0, and see what I get. So it's really more of a process that you have to understand, not really a super difficult algebra. Okay, and then you just solve it separately. If I can get down to x equals, I know I'm done. Okay, any addition, subtraction first, then any multiplication, I just do the opposite, right? Oh, I have a plus 5. Okay, let me subtract 5 on both sides. 2x equals negative 5. Okay, divide by 2, just like we did on the last one. Negative 5 over 2. Perfect. Or call it negative 2.5, right? If the decimal has an end to it, you can use it. So either one's good, negative 5 over 2 or negative 2.5. That should be an x-intercept. That should be a root for this function. Same thing here, right? Add 1 to both sides. Okay, 3x equals 1. Divide by 3 on both sides. So put a little plus 1 if you like. Divide by 3, but 1 over 3 is 0.3333333 forever, right? So I can't use the decimal. I gotta use the fraction in that spot. Call it 1. And it should work. All I have to do, and if you guys aren't sitting there grabbing these when you're doing them, I feel like you're missing out on an easy way to make sure your answers are right. Just look at it. I'm giving you the function 2x plus 5 and 3x minus 1. There it is, that 0.333 keeps going. I can't use it, but the negative 2.5, that one's perfect. So I can't use that one. I'd have to call it 1/3. This one's good. Questions? I want it to be pretty easy. It's not difficult. As long as you know what to do, you'll be good. Okay. Couple questions like this. Tomorrow I'll send them out, and certainly it'll show up on the final, so that we can make sure you've got that before we move on. It's kind of backing up a step or two that gets us to here. So, but that's it. There's a beginning of 2.3, and there's the end of semester 1 new stuff. That's it. Okay. Algebra 2, semester 1, done. All right. A little bit of homework for tomorrow. I'll call it homework. And then your review that you'll get sent out to you at the latest sometime on Wednesday. But hopefully before that, maybe I'll write it tonight and send it out as soon as it's ready. Broken up into sections for you to choose to do for extra credit. Submit for extra credit anyway. You should do it regardless of whether you submit it or not. That's up to you. Submitting it for extra credit. The quality of the work, how nice it looks, all that good stuff, contributing to how many points you get. Okay. Because some of us are sitting at grades that we're probably not happy with yet, and I would much rather give you a boost going into finals than knock you down a peg or two going into finals, knowing that you're going to have to take this stuff online and you'll have to be super organized and you just have an hour and a half and you have to be able to flip through your notes. If you've got the review done, it's sitting right in front of you, you just kind of go to that section, go to the notes that go with it, and you'll be good. Okay? And use a calculator to help you out. Use your notes, nothing else, and go from there. That sound good? Questions?
Later, Rosie. Have a good day.
Thanks. If you guys are good, you're good to go. Check tomorrow's announcement for how to take your own attendance.
Thank you.
And what work you need to do to be ready to go for Wednesday.
Thank you.
You're welcome. See you guys. Thanks for being here.
Thanks, Rosie.
See ya.
Thank you, Rosie.
Thanks, guys.